박수로 맞아주세요.
Hello. Everyone say cheese. Thanks for coming. All right. So we're going to talk about Polymer for the next 40 to 45 minutes. I'm really excited about Polymer. Polymer is a new library for the web that we're building at Google to help developers use web components. So a little bit about myself. So you know who's talking to you up here. My name is Eric Beitelman. I work on the Google Chrome team as part of the developer relations team. You can follow me on Google Plus or Twitter or my website there that I try to blog on, but unsuccessfully very much. HTML5 Rocks articles, I write a lot of stuff for HTML5 Rocks. So if you want to learn about all this cool stuff I'm going to talk about today, feel free to visit those articles there. Does anybody see the Easter egg in this picture? There's a little, it's the incognito guy for Chrome. He's on my glasses. It's pretty cool. So web components. What are web components? How many people have heard about web components in general or the technology behind it? A couple of people? Okay, you guys are in for a real treat. Anybody that is a web developer in the audience, I think, it understands this stuff once they see it. It's very, very powerful. And there's a lot of stuff that the browsers are adding in order to make developers' lives easier. So web components. An example of a web component. The blink tag is back in the browser. But this time, you can implement it as a new custom element. So essentially, that's what web components are. That's one sort of facet of web components. You can implement new tags in HTML. And this one, it doesn't use the browser internals. It just uses CSS animations to do the blinking effect. You guys are probably familiar with this one here. But what this Gangnam Style tag does is somebody declares this tag on their page, and boom, as soon as somebody hovers over this little thing, it plays the song using the web audio API. And there's a little dance using CSS animations. It's kind of a silly example of a web component, but again, all somebody has to do is declare this thing on their page, and they get all this other stuff for free, encapsulated in this component. But we can do more than just regular tags or silly examples. We can actually wrap up entire sort of applications and functionality inside of a tag. So as a user, I can declare the photo booth tag on my page. And this particular example just wraps the get user media API that Alex talked about. So I'll allow that. So it runs a little bit of JavaScript in the background, right? And so as a user, I just have this thing on my page, and boom, I have photo sharing sort of video capabilities with a little CSS filter action right on my page. And it's even got an API to do snapshotting, which is kind of cool. Just renders out to a canvas. But again, all of this comes for free just by somebody putting that on their page. It's getting kind of crazy. If you don't like the way the native HTML elements behave, say you're not too excited about button, doesn't look really good, you have to add a click handler to it or something, you can create a web component that says my button is a special type of button. It's going to be a mega button. And this mega button is not a normal button. It actually, when I mouse over it, it has some crazy CSS, right? And it's actually got a default behavior that moves at you. So again, kind of interesting and silly for the web, but I can basically redefine the way native buttons behave in HTML by using web components. So if you take a look at actually real-world examples on the web today, a really sort of quintessential example is a tab component, right? These are everywhere. Every library has a tab component. This is what it looks like in jQuery. There's a bunch of markup. Some of it's meaningless to me. You're overloading sort of ULs and LIs. This is what I believe YUI does, right? Instead of a declarative markup approach, they've taken more of a JavaScript approach, an imperative approach. So you include your HTML in JavaScript, and then you call like a render method. This is Angular's version of creating sort of what they call directives, custom elements, their version of custom elements. And so you write a lot of JavaScript code. And the reason all these are different is because the APIs in the browser, in the web platform, haven't existed until now to be able to really, really define what a tab component means semantically and easily and consistently across these different frameworks. This is Kendo UI's version. This is Sencha's version. Everyone is different. It's pretty insane. It's insane as this picture. But what about not just components, right? What about whole applications, right? if you take a look at the DevTools, if you open up Gmail, how many people think that this source code is readable? Can you? Yeah, nobody, exactly. So it's all divs. We call this div soup. It's meaningless to a developer. I can't maintain this. I have no idea what it's doing. You know, some of the stuff is obfuscated for performance reasons, but at its core, we don't have the primitive tools to describe what Gmail should be. What? What? This is how we build web applications, you guys, and it feels really dirty to me. But what if Gmail chat, for instance, looked like this? What if it was meaningful again? What if markup was meaningful? So instead of a bunch of divs, I had something like a Hangouts module tag, right? A custom element to describe this. With inside of that, we have a Hangout chat. I'm chatting with Paul and Addie, right? Just an HTML attribute that I've added. My profile ID is included on this HTML element. Inside of that, I have a discussion tag, right? This is totally legible. It totally makes sense. And each one of these tags is a message, and it's got semantic data, such as my profile, the date and time it was sent. And it really just makes sense from a developer standpoint. I have a demo of this. This is my web component, my Gmail chat hangout web component. I'm talking to Paul Irish down here. And I can type to him. I'm going to try to type with one hand, just a bunch of characters. I can create a new component, and each one of these, I'm talking to Larry Page now. He knows Spanish. But these have functionality, right? These components wrap up this collapsible widget. I can add new ones. And if I dive into this, using the DevTools, I can see that ultimately what I've implemented here is that the Hangout module, inside the Hangout module, we have a bunch. We have the discussion tag. And inside of these, we have the custom element Hangout message. And so I've done this using Polymer, and that's what I'm going to talk about now. But it just makes sense when you're implementing this stuff using web components. So this feels really good. I'm really happy about this direction as a web developer. So the better tools that we're adding to the web platform come in sort of 3 or 4 different flavors. And the whole web components notion, the sort of this umbrella term, is made up by several different specifications. And so the first is Shadow DOM. Shadow DOM is a new API that we're adding to the browser that allows you to do DOM and style encapsulation. So styles don't bleed into your component. Styles that you define inside don't bleed out. That makes a lot of sense when you're talking web components. HTML templates. Proper templating in the browser, the template element, allows you to define sort of sections of markup to be used for later. This is really handy when you're stamping out a bunch of dynamic DOM. Custom elements is another specification as part of web components. And this is sort of the core API behind this stuff. It allows you to create new tags and tell the browser about the Gangnam style tag or the photo boot tag. And you can also extend existing elements if you want to. And the last piece of the web component sort of ecosystem is what's called HTML imports. And this is really cool. It's a very simple API. Essentially, we get a link tag, and instead of a rel style sheet, it's a rel import. And you can reference an HTML file. And it's essentially like a pound include, if you're familiar with C++, for the web. You get to bring in another file of HTML, CSS, and JavaScript all bundled together, and then somebody can bring that into their page and start using it. So that's really cool. It's a way to distribute and bundle common markup, common JavaScript, and common CSS. Alongside of these 4 main specifications, we have sort of other primitives that we're adding, that the browser is adding to do things like data binding, right? If you're making a web application these days in a framework, Angular, Ember, one of these frameworks, likely is that you're going to be using data binding. This is really popular. And so some of the primitives that are going to allow this to be native in the browser are things like object.observe. So being able to get changes when a JavaScript object changes, get notifications of what's going on, what has changed. And so that increases performance and it allows you to write really slick web apps. Template is an example, being able to stamp out dynamic markup. And mutation observers, sort of the equivalent of object.observe in the DOM. So being able to decide and make modifications when DOM has actually changed. So if somebody removes a node, you can get sort of a notification for that. So all in all, a bunch of new APIs. I'm not going to talk about these at any detail today. I'm going to talk more at a high level at the Polymer level. But essentially, they're a collection of new APIs that you as web developers can play with. All right, so let's talk about Polymer. So what is Polymer? How many people have even heard of Polymer? Cool, a couple of people, awesome. So my take on Polymer is, and the goals of the Polymer is that it's a new library for the web. It's a JavaScript library. It's built on top of web components. That is very sort of at its core, web components, and the specifications that I talked about before. And it's designed to leverage the evolving web platform in modern browsers. And what that really means is that we want to teach developers how to use some of these new APIs and use them all really well together. As you've seen in this last slide, right, there's a bunch of new stuff coming. We want to sort of highlight an opinionated way to use all this together. Each one of these technologies can be used totally separate by themselves. That's part of this sort of magical picture. But together they really sort of form an awesome, awesome story. So what is Polymer? This is a diagram that we have. It's our sort of architectural, conceptual diagram. First, it's a library. It's about 48 kilobytes for the evolving web platform. And it enables the use of things like custom elements and pointer events and shadow DOM and HTML imports today using polyfill libraries. And so we actually have, as I mentioned before, an explicit goal to support the latest version of every browser. And one reason behind that is because polyfilling something like shadow DOM, which, if you are familiar with the details or you read more later and your mind sort of warps because it's a very, very complex topic. And actually supporting that in older browsers with limited JavaScript capabilities is almost impossible. So it's a polyfill library. That's this red layer. That's sort of the foundation all of Polymer is built on top of. It's built on top of web components, and you can think of that red layer as that foundation. The next layer up, the yellow layer, is what we call the Polymer sort of core library, the sugaring APIs. It's a little bit of extra special sauce, if you will, that sits on top of the fundamental APIs, but it makes things really easy for you to develop. So I'm going to show you some of those examples in a bit, but it makes developing web components a lot easier. Let's just put it that way. And it also expresses our opinion on how to use these different APIs together, which I think is really awesome. One level up from that is the green part. These are the elements. So we're interested in building a comprehensive set of UI elements and just general awesome utility elements for the web. So these, again, sit on top of web components. They use the Polymer core, and they sort of represent the visual layer of what we think web components can be. So it's a lot of stuff, and we have three main philosophies. And basically, you'll hear me say this again and again and again, and that's to utilize the modern web platform. We want to sort of push the limit of where the web can go. The second one is interesting, and it's conceptually hard for people to understand this when they first are introduced to web components. And it's that everything is DOM. We really want to make markup king again. You saw the example of the Hangouts chat, right? That's all declarative. It's very declarative, and as a user of that code, it's very easy to write in a web app just using markup. The browser understands HTML. So everything is an element, the green layer. And the last one is eliminate boilerplate. Who likes to write a bunch of code over and over and over again? I should put my hand down because I hate that. And we do too on Polymer. We want to make your lives easier. Nobody's going to use web components if you have to write 1,000 lines of code just to get one component done. So we want to be opinionated. We want to teach developers how to use this stuff. We want you to be able to sort of pick and choose the parts you want. If you remember the architecture stack, you can sort of, as a developer, come in at any one of these levels and sort of pick and choose the part that you want to develop on. If you just want to use the raw APIs, you can use the polyfills. If you want to use the special sauce, you can use Polymer Core. If you want to use our elements, just drop them on your page, and you don't even have to worry about doing any development. That's totally cool as well. And we want to evolve with the web and be a constant feedback loop to the standards process. This is really, really important on Blink and Chrome. The Polymer team is constantly talking to the Blink engineers, the Chrome engineers about performance issues, or how do I do this, or why is this sort of slow in the browser? And so we want to sort of inform and make these APIs rock solid for developers to play with. So I want to invert that pyramid and start with the elements. I want to sort of highlight this notion of the green area, which is embrace DOM, everything is an element. What does this actually mean? So the first thing that we have is actually this Polymer Ajax element. This is an example element that we've created. And so we can actually perform Ajax using DOM, using markup. What? That's crazy. but it's actually really, really powerful and really cool. So we have this Polymer Ajax element, and as a user, right, I put this on my page, I give it an URL of a JSON feed, for instance, and it's also got this configurable params attribute that I can pass in a serialized JSON object. So we're going to essentially get this feed, right, this YouTube playlist as a JSON feed. So I drop that on my page, and I read the documentation about this particular element, and I recognize and see that it fires this Polymer response event. So when that feed has been processed and the request has been made under the hood on that element, I can listen for that event and then use your standard JSON parse to get at the data that it returns to me. So I can run this real quick and show you exactly what I have on this page. So I have just this element declared on this page. I'm listening for this Polymer response, and boom, I have my instant playlist of YouTube videos. So the important takeaway here is that it's just markup, right? The only code I've written is your standard query selector, your standard add event listener. It's just DOM, it's just HTML elements. I've just defined sort of a new functionality, a new behavior, and that's being able to do Ajax using markup. That slide is out of place. Everything is an element. What about, we can do things like reading files in DOM. So how many people are familiar with the file reader API, being able to read files in HTML5? So you can do this. This is a file reader API. And what this element does is essentially wraps that JavaScript API. So instead of writing a bunch of code, I can just declare this Polymer file on my page. And I can configure this read as attribute that it defines. I can decide to read the file as a data URL, an array buffer, a binary string or text. This sort of just maps to that JavaScript API. And same type of deal, right? I'll wait for the Polymer result event. I'll attach that listener. And then I can process this elements.result property. This file object also has a blob property you can set. So this is how you actually pass in the file to read. So in this case, I'm just setting it to this string ABC. And then I call its read method. So this Polymer file element has an API, right? It's got a read method. It's got a result property that I can get at that data. And all I do, again, is just declare this on my page. So I'll hit run. And boom, I've read this file that I've set using the read method. It's giving me a data URL back. And if I open that, you can see up at the top there, the data URL that's produced is that ABC. So that's really cool. You can imagine attaching this element to a file input, for instance, and then having the user select files and then reading that using nothing but markup instead of a bunch of JavaScript. Everything is an element. What about things like layout? Right, we have CSS for layout. What if we made that more declarative? Something like this. So we have a Polymer Flex layout element that we've created. And these are ideas we're sort of toying with, right? What does a web component look like that is sort of a utility element? It's responsible for managing its children. So this Polymer Flexbox layout essentially wraps CSS Flexbox. And it's got parameters that you can configure. So it's got this vertical one that my children are being rendered in a Flexbox column right now. Instead, I can switch this. So if I declare this element like this, right, without that vertical attribute, that container knows what to do with its children. It applies the CSS for Flexbox. And you can see that now I have Flexbox in a row orientation. Inside of it, I can also customize how my elements flex using this special attribute that this element knows about. So all of this stuff is sort of wrapped up and encapsulated, and this particular element is aware of its surroundings, essentially, and it renders stuff using Flexbox. I don't know if you guys have tried to use Flexbox, but it's a little bit difficult to understand sometimes. And I can add a bunch of children to this, right? And each one of these just knows what to do because it's part of this container that understands CSS Flexbox. I can reorient these. And so it all just works. And so this is really cool because we're using an element to do layout. And structurally, you can read this and understand exactly what's happening. And we're actually working and sort of experimenting with a number of different non-visual elements. So these are a few examples that we've been toying with. So you have things for layout like Flexbox and CSS Grid. We have a couple of tags to do views. So Polymer Page is sort of a single page app type thing that you can implement a single page app. Elements for libraries, things to bring in shared state and Google JavaScript libraries. A couple of data elements. So this is really cool. This one, Polymer Local Storage, essentially just wraps the HTML5 local storage API. You give it some data, and boom, it just handles storing that data for you offline. You saw Ajax and JSONP. And there's also things for behavior interaction that we're experimenting with. So signaling, right? Sending events to other components and sort of notifying those. A Polymer selector, being able to do like tri-state, sort of a selection type widget. These are very common things, a lot of these that you do in a standard web app, and we've essentially just packaged these up as an element that you can just drop in your page and start using. Conceptually, it's a little bit weird that you're including some markup on your page like Polymer local storage. It doesn't render anything, right? It's sort of this utility element that just exists on the page. But once you sort of see the examples later on, I think it'll really start to make sense. So as part of this green layer as well, this Polymer stack, we're also experimenting with the UI that sort of sits on top of these core utility elements. And just a couple of examples here, right? You have your standard tab widget, your toggle strips, your toolbar elements. You have things like Polymer UI card, which essentially gives you sort of swiping capabilities, right? So you just drop this on your page and you get touch for free, you get swiping for free, which is really, really nice. You don't have to worry about any of that stuff anymore. Your sidebar type menu item, implementing some widgets that sort of follow you and this arrow that follows you. A lot of this stuff is just really natural in the world of web components. And this one's pretty cool. This one, if you Polymer UI theme aware, if you embed this within a container, the whole sort of page or the container takes on the theme that you specify. So it's a really kind of an interesting and cool way to do theming of an entire web app just by placing in one tag. A lot of these, I will mention, the UI, Polymer UI, use those underlying non-visual elements to get the job done. So they reuse the components, and that's actually one awesome benefit of web components is that they're reusable. You don't have to start over each and every time you create an app. You can reuse existing functionality and sort of mix in new functionality. So that's a little bit about thinking, declaratively as elements first. Now let's talk about how you actually build a web component. And that's where this yellow layer, the Polymer Core Sugar APIs come in. The philosophy of this section is we want to eliminate boilerplate. There's a lot of tedious code that you have to write in order to sort of work with these standards, the shadow DOM, the custom elements, and we want to make that very, very easy. So we're taking a declarative approach. The first couple ones you'll see here, core features of Polymer, they're all declarative, right? So instead of registering elements in JavaScript, you're declaring them using what we call the Polymer element syntax. You can extend elements very easily with this extends property that we have. You can do things like data binding, right? So if I want to data bind this input's value to the foo property, I can do that with the double mustache, very similar to any other framework out there. Declarative events are pretty cool. You don't have to do things like attach an event listener. You can basically just use on dash whatever event you want and then give it the handler that you want to be called. Publishing properties, a lot of this stuff I'll go through, being able to detect when a property changes, right? Somebody changes something on your element, you want to be notified for that, and you get a callback for that if you define it. So the moral, right, the takeaway here is that we want to be declarative as possible, and we want to write less code. And what I mean by writing less code is something like this. This is an example of creating a custom element, my-input at the bottom here. That's the tag we're creating, without using Polymer. This is what you have to do. So the first thing is you'll have a template tag with some markup that you'll declare. Maybe it's got some styles in it to style this input. And then you write a bunch of JavaScript. You write a prototype object. You create shadow root, right, using the shadow root API for this. And it's kind of messy, right? This is very repetitive. If you're implementing a web component, you'd have to do this each and every time. And then you call document.register at the bottom here. So instead, what we've done is we decided to take a declarative approach, right? We want to sort of preach and practice what we preach. And so instead, in writing a bunch of JavaScript, you declare a Polymer element. So you just declare this using this special tag, which itself is implemented using the primitives, right? It's implemented using document.register, which I think is really cool and sort of an inception moment. But you declare Polymer element, the tag that you want to declare, my input. You can pass it a constructor, so people can use the new operator in JavaScript to create you. And the important piece of this particular example is this noScript attribute here. And that basically just means this element is dead simple. It's just a bunch of markup with some styles. It doesn't have an API in JavaScript. It doesn't have any properties that are set. And then we just include that template that we had before in the previous example. And that's how you define a custom element using Polymer. It's all declarative. People can then declare my input on their page. They can create it in JavaScript using create element, or they can use new. The point is, it's the same web platform and APIs that exist before. You're just allowing developers to create new elements. If you want to, we can use default attributes. So this is pretty cool if you have something like Bootstrap, right? And you want to include maybe a common CSS class on every element that's created. In this case, including other attributes in your Polymer element definition will include those on the element when it's created. So somebody declares my input on their page, and every instance that's created in the DOM will actually include that class active in that custom attribute. But as you saw, right, we have more complex elements. So what about the photo booth application or the Gangnam style application, right? At some point, you're probably going to need to define an API. You're going to need to give your element some properties, some functions. So what we can do with this is actually take off the no script at the top, and we can inline some script inside of our Polymer element definition. So now we're working with markup, we're working with styles, and we're working with script inside of this self-contained sort of component. So we'll call the Polymer constructor and pass in the name of the tag we want to create. The second thing we can do is we can beef this thing up. So we want to give it a couple properties. We can give it a type property and default it to text. We can give this element a color property and default it to orange. And we can also define methods, such as the created callback, to be notified of when things happen on our element. And so essentially what we're doing is defining an API for this element. I will also mention that we can clean this up quite a bit if you want to. Your standard sort of web development best practices still exist in the world of web components. So instead of having inline style tags, if you want, you can reference a style sheet. Instead of referencing inline style or script tags, you can reference an external JavaScript file. So if you're a fan of CoffeeScript, if you're a fan of Less or Compass, right, you can totally use those precompiled languages and then embed those inside of your component to use. It's also, for those that are familiar with content security policy, CSP, this is a great way to get around the issues that CSP has. Where this really gets sort of magical is through published properties and data binding. And this is sort of one of Polymer's core features and what we think is very, very powerful. So this is the exact element that I had in the last slide, right? It's got that input tag, and we're making a special input. The only difference here now is that I have this inline style tag for the color. So I've just moved that from a style tag just directly on the element there. But you can see there's a little bit of an issue here, right? I've got this type property in my element, and I've also got this color property in my element, but they're being duplicated in the markup up at the top here. That's kind of ridiculous. So why don't we switch those to mustaches? So instead now we can use data binding to tie this element's type property and its color property to the values of that input. So those two are now linked via mustaches and data binding. Very, very cool. Something else we can do is we can publish these properties. So using this attributes attribute on our Polymer element definition, I can say I want to publish the type property of my element and my color property and allow users of my element to actually pass in those as attributes. So you can see as a user of my element, they can override my default orange color with the red value using an attribute. So that's what the published properties do. It essentially takes your JavaScript world and says, OK, allow people to customize me via HTML. And that's where the declarative sort of nature comes into this as well. And we can go crazy with this. We can add a bunch of data binding inside of our element and link things together just by using synchronous data binding. So for example, I can add a value property on my input and then link that to a text area. So every time somebody types in the input, my text area is just updated automatically via that data binding. So things become very, very powerful. And you ultimately have to write less code, right? You're not attaching event listeners or watching for changes. It all just works via the data binding and published properties. So a real-world example of this using some of the sugaring APIs in the real world is to reuse and use the Polymer Ajax element inside of another element. So maybe you're creating this new element. It's called YouTube videos, right? And then people can declare it on their page at the bottom here and query for cat videos or Chrome videos or whatever they want. And they can customize it just by this query parameter. So we publish that query string, that query property. Inside of Polymer Ajax, it's the same thing as we had before, but we're not writing any JavaScript anymore, right? From the outside world, we had to write JavaScript to listen for a response and process that using JSON. Instead, we can just set up data binding on some of the properties that it has. So for instance, it had that params property, if you remember from before. Instead of passing a serialized object, we can pass in a data-bound variable params. And so I can set that to an actual object in my element when it's created. So we have binding via object, which is really cool. Instead of using the alt JSON, it's got this awesome handle as parameter, if you read the API documentation, that we can configure it to do JSON requests. And instead of hooking up JavaScript, right, to process the Polymer response, we can data bind to this attribute and use a property. And essentially, when this file or when this request is made, the response is going to be filled, and we can do things like render out template data inside of our element. So synchronous, basically, you can set up binding for anything that cares about a certain property, right? And it just works. It just sort of updates itself. You can use the template element to repeat over the list of entries and print out an LI title for each one of those. And so that's really, really sort of a core fundamental thing of Polymer is using data binding. Another real-world example is reusing the Polymer file element inside of another element. So we can create this README element. And this one's pretty cool because it actually uses data binding as well. So no JavaScript here. Instead, we're binding to that result property it sets. This is a Polymer feature. It's called a changed watcher. So when my result property changes, my result changed method will be called. So that's really nice. You can observe properties really easily. And something else this element does is set up a default sort of declarative click handler. So instead of doing things like attaching an event listener, I just declare on-click and give it a string. And the string maps to a method on my prototype, on my element. And so when somebody clicks this element, it's basically going to start the file read, and it's going to call that element's API. It's going to call its read method. One other cool little feature is sort of this jQuery-like syntax that we have. It's called automatic node finding at the top here. And it essentially allows you to do $ dot and then the ID of an element within inside of your element to sort of get at things. So it's very easy to pull things out of the DOM. You saw an example of some of the things we've added to the template tag. So template, again, is a new primitive that's part of the Web Components collection of specifications. But what we've done in Polymer is sort of beefed it up a little bit. So you can do things like conditional templates. Just activate this section of markup if this property is true. And this is using data binding again. Or you can do things like expressions, right? If isActive is true or always shows is true, show this particular section of markup. In the previous example, you also saw iteration, right? And you can have multiple sort of levels of iteration, iterating over a property as well. So for users and user, stamp out this particular markup, and then within that you can have sort of named scopes. So this user has a files object that you can then iterate over. So really powerful stuff, creating markup dynamically based on a data model rather than just declaring it sort of statically. Another feature we have is anywhere you use mustaches, right? These double mustaches for data binding, you can set up expressions. So you can do things like addition, right? Jill has, her daughter's children plus her son's children equals her grandchildren, right? Something else is pretty cool is you can dynamically apply classes to elements internal to your component. So for example, if user selected is true and user type is super, right, it's going to apply the active class and the big class on my div there. That's pretty handy if you want to do sort of dynamic styling. And the last version of this is conditional attributes. And this is really nice for things like Boolean attributes. If you have a checked attribute with the checked and then the question mark at the end, it basically says add this attribute if this property is true. So again, really, really utilizing the data binding capabilities. And if it's not true, that checked property or that checked attribute won't be applied in the markup. I want to take you on a quick tour of sort of everything as an element and show you some of this stuff in action. This is a tool that we, actually I think I have it ready to go right here. This is a tool we sort of showed off at I/O. And it's basically a playground for you to come in and sort of play with elements. And these are some basic sort of bare bones elements that we've created. But it's essentially, I can show you some of these really quickly. We have our tabs widget, and it just works as you'd expect. We have a star rating widget that works. There's a toggle button, and these are some of the things that I showed. And if we actually dive into the code here, all right, you can see that everything is a custom element. We have the G tabs element, G ratings element, G toggle button element. But instead what we can do is we can bind these all together using Polymer. So I'll use the double mustaches, and I'll bind to this selected property, this attribute that it publishes. I can bind this value of the ratings widget to the same property. And someplace in here, well, if I add another one, what should I add? Let's add the menu, because the menu has different states. So basically this code just updated. It's got the declarative version of that G menu, and it's got also a selected attribute that is defaulted to 0. Instead, I'll just switch that over to using data binding as well. So now I've linked all three of these selected states to the same property. And hopefully, if I select one of these, you can see that they all update. So as I select one in one element, right, the ratings widget is changing. And there's an off by one error, but whatever. And the menu is also changing. And if I do the same, right, if I click this one, again, everything's just sort of kept in sync via data binding in Polymer. What's really neat about this particular app is that you can actually embed it inside of itself. So you can do sort of an inception type thing. And that's really thanks to web components, right? Everything is compartmentalized. Everything is self-contained and encapsulated. So you can have the app within the app, within the app, within the app. It's really crazy, but it all works thanks to Shadow DOM. So we talked a little bit about the elements. So everything is an element. What does that look like? The green layer, the core layer, which is the yellow stuff, data binding, changed watchers. And I really just want to iterate on the platform level. The stuff that Polymer is built on is ultimately the web platform. Right? We're not implementing a bunch of JavaScript. We're actually using the APIs that are being added to the browser. So a couple of things on this. The first is that if you're familiar with custom elements have the notion of lifecycle callbacks. These are methods that you can implement on an element that basically gives you notifications of when it's created, when it's inserted into the page, when it leaves the DOM, and also when an attribute changes. So you get to know what happens on your element. And Polymer has first-class support for this stuff because, again, at its fundamental level, everything is built from that web platform. I will mention one quick example of using something like this is maybe you have a really complex element that opens an IndexedDB database, right? Or you're doing something very complex. And then when the element actually is removed from the DOM, you want to do cleanup. You want to clean up the database, you want to close it. And that's what these methods are really designed for, is to be able to do complex things like that. Insertion points are a complex topic. It's part of Shadow DOM, but Polymer also has first-class support for this. So insertion points are really cool because you can say, you can have a user use your tabs widget, for example. And they include a bunch of markup inside of the tabs widget, maybe title tags that are H2s and section tags, right, for the content itself. And inside of your Shadow DOM, right, the Polymer element, the web component, you use content tags. These are insertion points. And you can select out very specific markup from the user's markup and render that into particular locations inside of your element. And so it's really cool because you can say, I just care about these particular elements, and I'm presenting you to look like a tabs widget. So I actually have an example of this. It's a little experiment I did using AngularJS, which is an awesome framework. And at the top here, you have a web component version, and you have an Angular directive, their version sort of custom elements at the bottom here. You can see the markup is strikingly similar, and I've designed it to look that way. But the code, right, is very different. So the code for Polymer is the Polymer element. It's all declarative and whatnot. And Angular, right, they have their own API to create directives. But the really neat thing about this is that you can, because everything is an element and everything is DOM, I've set up data binding using Angular's data binding. So this is an Angular application. I have my web component here, and I'm binding the heading property to this attribute here. And you can see the Angular version also has this same attribute. So now these two are linked via data binding. And so this is outside of Polymer. It's two frameworks sort of working together. And you can see when I update this, right, both of those headings are updated. And that's really the core concept here, is that everything is DOM, and because everything is an element, it just feels like native HTML. Nothing has changed. Shadow DOM also has the ability to do scope styling. Really, really awesome feature of Shadow DOM. All right, so styles don't creep into your element. Styles don't bleed out. Anything you define in it will just sort of be there. The two properties that Shadow DOM has for this, apply author styles and reset style inheritance, are also first-class citizens. You just define them on your Polymer element definition, and then that's how you control sort of the look and feel of your component. The last piece that we have first-class support for is HTML imports. And they're really, really simple to use, right? You just declare a link rel import and reference an HTML file. But this becomes really powerful when, say, I create a new component and I want to reuse someone else's toolbar. I really am a fan of somebody else's toolbar. I really like their menu item tag. I can use two imports to bring those into my application and then define a new element, right? Define an awesome menu element and reuse those toolbar menu items inside of my own element. And then package this up using an import, put it up on a URL someplace, and people can then bring this whole package into their application. So they can then use my awesome menu tag just by referencing my resource. So this is really, really cool, because you can imagine a world where something like Twitter Bootstrap exists as a web component. And so you get all the CSS, all the JavaScript, and all the HTML as one relocatable resource. That's something new that the web hasn't had before. So Polymer is many things. This is, again, our architecture stack based on the foundation, the core set of specifications, the sugaring layer, the elements that we're building. And on top, the little guy on top is the blue part. That's the apps that you're going to build on top of web components using the entire stack or just pieces of the stack, whatever you want to do. I encourage you guys to absolutely go and check out our website, polymerproject.org. It's actually a shining example of using web components. So we're sort of dog fooding web components all over the place. Our build page in particular has these little widgets on it. These are just Polymer elements, web components. So you can see that this uses the Polymer Ajax element to query a resource and get the data back if tests are passing or not. Looks like we're doing pretty well today. And it's also got more information on the elements and the core technologies. If you want to learn more about that red layer, the sort of platform layer that's being added to all the modern browsers, I encourage you to check out my presentation at Google I/O, webcomponentshift.com. Again, the HTML5 Rocks articles are absolutely amazing and very, very detailed. So if you really want to get down and dirty with this stuff, go check out these resources. Lastly, I will leave you of why you should be excited and why I'm excited for this stuff. As a web developer, my productivity is actually skyrocketed building stuff off of web components. Again, I can create a component and reuse that everywhere. It's DOM, it's JavaScript, and it's CSS. You saw the tab example before with the jQuery version and the Ember version and the Angular version. They're all different. What if they all built their tab components off of web components and the APIs were very easy and intuitive to use? You can say what you mean again, right? Somebody else can read my markup that's just a bunch of custom elements and really understand what's going on in the web application that I'm creating. Reusability. Don't reinvent the wheel. Interact with other frameworks. You saw the example with Angular talking to a web component. And the last one is good software practices, right? Good paradigms that we've used all over the place in other languages, bringing those to the web. So thanks to Shadow DOM, right, we have things like object-oriented programming to some extent. We have encapsulation to some extent. And that's stuff that hasn't been able to achieve before outside of the world of web components. So with that, I really appreciate you guys' time. Thank you for listening to me ramble to you up here. Hopefully I didn't speak too fast. I will put these slides up on a URL someplace. Feel free to follow me on Google Plus or Twitter, and I will post the links there along with the demos and stuff that you saw today. So I'm happy to take questions now or later. Thank you for your time. You guys all just blown away? Yeah, question.
Yeah, thank you for a very good presentation.
Thank you.
So my question is that one of issues for Polymer could be deployment for all our browsers.
Yeah.
So could you share current status of that?
Sure. Yeah. As I mentioned before, whoa, I just totally slid out. As I mentioned before, actually one explicit goal of Polymer is to support the latest version of every modern evergreen browser, which means the browsers that update themselves. And one reason we really wanted to focus on this is one, for technical reasons. It's very hard to polyfill certain APIs in libraries that don't support certain JavaScript features. Because ultimately everything that this sits on is enabled through polyfill libraries in JavaScript until the browsers have these modern APIs. You can get rid of that red layer completely, right? And the other reason is that we want to sort of stay up to date with the web platform. So as things like web animations get added to the web platform as the native API, we want to use that right away in Polymer to do really cool, slick animations for our elements. Things like pointer events, when those are native. Some of this stuff is never going to come to older browsers, so it's going to be very hard for us to sort of envision and show developers really the true path forward. Having said that, we have pretty good support across the board for the different browsers, and mobile is also pretty well supported. But super old browsers, unfortunately, it's very, very challenging. Question, yes?
Yes, I'm wondering what's the performance implication of web components. I think it should be in between using existing technologies like Enyo or Zepcha, or the other you could actually extend the sort of browser itself. So, and I'm wondering where using a component should be in the spectrum.
Yeah, that's a really good question, and I'll just repeat it for anybody that didn't hear it. The question was, what's the performance characteristic of web components compared to other sort of libraries and frameworks, essentially? So one thing about this is, right now, if you use Polymer in a browser that doesn't support the native APIs, you're going to be using libraries, right? You're going to be using JavaScript libraries. One reason frameworks exist today is to help developers build web applications, and they've gone through sort of great lengths to implement their widgets, their libraries, their core APIs, because the primitives, these fundamental technologies of the platform, Shadow DOM, custom elements, haven't existed. Now, I can imagine and really hope we get to a point someday where frameworks every framework uses a lot of these platform capabilities. So the whole web sort of gets faster because everybody's using sort of the raw APIs added to the browser. Excuse me. Right now in Polymer, you get libraries, but in browsers that support these APIs natively, things are much, much better, right? You can use the native platform APIs, so it's part of the browser, it's part of sort of your stack. And so that's really the cool part about this, is that if you choose to buy into web components today, it's sort of that extra layer of library sort of goes away. And so things just automatically work and get faster. Performance in general is, I think, a very challenging topic because it covers many, many different facets. So I think you'll hear some really awesome presentations today, and everything from rendering to network to browser and JavaScript performance. Yes?
I see the yellow road there. How far can you go with Internet Explorer?
Yeah, this table is not even that up to date. Internet Explorer 10 is the browser we're choosing to support because it has some of the JavaScript APIs that allow us to polyfill Shadow DOM. Having said that, it doesn't have mutation observers, which I think is why this has limited usable. So IE 11 just came out, which has mutation observers, even though they're a little bit flaky. So that is going to be really the true version of IE that is going to support a lot of this native stuff. Any other questions? Yes?
I think there's tension when you make a new component. The author may or may not want the users of the new element to tap inside the element, the new element. And on the other hand, the user of the new element may want to change something or may want to define a variant of the element by, for example, inheriting the custom element.
Yeah.
Do you have any control over those dynamics?
Yeah, so the question was, how much flexibility do you have controlling when you use somebody else's component on your page? Can you customize it yourself? Can you like drill into it and maybe tweak it a little bit? And then also, maybe as a component author, can I do things sort of outside of my box? And the answer is yes. So this is the web platform. You can do anything you want, right? It's JavaScript. You can do anything you want to limited capabilities. And that's part of what Shadow DOM gives us, is it raises the bar to be able to sort of drill down into things. It gives us things like DOM encapsulation and styling encapsulation. But in JavaScript, I can totally, as another developer, drill down into someone's Shadow DOM and maybe tweak things if I want. And that's just sort of a fundamental way the web and JavaScript works. You can also say as an element to consumer, right? If I'm using somebody else's tab strip widget, I can choose to bring that into my app and then extend that. If I don't like the way it looks, if I don't like its APIs, if I want to add new and additional APIs on top of that element, I can choose to extend that element using web components and the extends attribute, and then give it a different look and feel, or flare it up with some extra APIs. So the APIs in general are there to help you do things like that, but they also allow you to sort of have this encapsulated world as well. So there's some guarantee that your component remains a component how you intended it to be. It's a good question. Cool. So I think we're out of time. Feel free to come ask me questions anytime throughout the day. Thank you.